Hello everyone, let's have a general discussion on this multiple linear regression. What is the process type? We need to know the stepwise process to accomplish the multiple linear regression. So I will just guide you through that. Okay. I wrote as a process type. So let's talk about it. What is this? What do we need to do to in order to use this model? So first of all, this before moving to the multiple linear regression, right? Before that, you need to understand the simple linear regression. So whatever the variables you are taking from there, right? Those should fulfill the simple linear regression. I mean to say that this is the revised or advanced version of simple linear regression, right? So it should satisfy the simple linear regression. I mean to say the variables has to be fitted for simple linear regression. So simple linear regression means those variables has to come across the process of simple linear regression. Maybe there has to be dependent variable, has to be a normally distributed or diagonal, those things, right? Then those independent variable are comparing one by one, and if it is significant, that model is significant, then only those variables can be taken to the for simple linear regression. Likewise, those significant variables has to take here as to test for multiple linear regression. So you have to just add the simple linear regression terms. Okay, so variable has to be fitted to simple linear regression and got there as significance. Okay, significance for it. And next, what we do here, one more additional things. You already know that Pearson correlation coefficient is there, right? Coefficient. Those predictors should not have a correlation with each other. I mean to say, for that better version is variance inflation factor, something, so BIF. So better is BIF, right? So actually we say that Pearson correlation coefficient, those variables, those predictors should not have correlated with each other. Meaning is predictors that do not correlated with each other. So BIF less than 10. Except, okay, I mean to say those variables has to be less than 10 BIF. If you use BIF, right, basically in programming we used R programming, like R packages. From R packages we just write like this. We talk about R, what we do BIF. Okay, let me give you one example. It will be better. Suppose let me write multiple linear model 1, model ML, multiple linear regression. What happened here? LM, linear model. Suppose income is your predictor. I mean to predicted income has to be, I mean to say, dependent variable, right? Predicted variable, dependent variable. And here several independent variable. Age plus, right? What other things? Age can affect education, right? Education. For categorical variable, you add factor, right? Education. What? One more. Education literacy skill, right? This is also, if it is categorical, we have to write categorical before that name and wrap that variable inside, right? Literacy. So those are the variables. Suppose we give data equals to df. From df we are, suppose consider df we are extracting those things, right? If you check VIF here, suppose VIF, what this model NM. See, a VIF table gives, suppose age has a 8.2 VIF. Okay, that education 22 you got as example. Okay, for other thing is what is literacy. Literacy you got somehow 11, right? So those are the VIF. What our formula says, VIF less than 10 you should keep for multiple linear regression. So in order to fit the model, what you do, you have to keep less than 10 VIF values. I mean, so which one we need to remove? I said highest, right? This is also greater than 10. This is also greater than 10. Sorry, greater than 10, right? Consider highest we take. Highest means we take this. So this variable, what we do next time when you make equation, we make LM income as it is which one we are removing? Education, right? We'll not keep education, we'll keep this one, literacy we keep. Now our output comes like age has 17, 8.2, then suppose literacy 9.2, something comes means, so this can be accepted, right? Likewise we need to work. So age and literacy can be, those variables can be accepted because it has less than 10 VIF, right? Less than 10 VIF. Now we removed education from here. So because this we should not consider as per our theoretical understanding, right? So now how model, your model, final model, how it looks, NM, income, tilde, we call this as tilde, age, plus what we keep, we have removed education means we keep factor literacy variable. Now this is the final model, and we can call this as a blue estimated, right? Blue. So blue estimated is done, right? Blue, best linear unbiased estimation. Now we need to do line also, right? What we do in line for linearity, what we do, scatter plot, right? Scatter plot, predicted value, what? Predicted value near 0. So near 0 should come, right? For that, what statistically what we do is we call that variable, suppose fitted value something, and then we take mean. So if it is comes 0 or near 0 means we have achieved linearity, that you should consider. Then I for time series, we don't need time series. ACR plot we already discussed. ACR plot, Darwin-Watson test, Watson test, right? T value is greater than 0.05 which we accept, right? This is not needed right now. And normality, what we do? Normality. For normality, we check this histogram or we check cubic plot, right? If this histogram cubic plot is not good, then we do Sapir-Whorf test, right? We do Sapir-Whorf test, and where p value should be greater than 0.05. This is also GOM test, right? So this is normally distributed we can say. Here also GUF test. Okay. Now ultimate last one, what E part is there, right? Equal variance. What we do for equal variance? For equal variance, we predicted value scatter plot. This is also scatter plot. Predicted value and residual value. Value. What it talks about? Randomness. Right? If this has my writing may not be clear, but you heard my voice. Okay, that is fine. Then what happened? You first install library you call car library, right? Bruce Wagon test, right? Wagon test. What you do here? P value is greater than 0.05. GUF test. Insignificant means this equal variance is achieved. Right. In programming, you do something NCV test. Then keep that model inside variable. Then output should be more than 0.05. Thank you.